All right. Good evening, all our students of Ask IITians. Welcome you all to the Ask IITian platform, and this is our next session for the NEET 2024 discussion. I hope you have checked all your answers for question number 51 to question number 75. It was code Q6, and in this session, we are going to start from question number 76, right? All right, so let me just go back a bit, and here we go. All right, so let's read the statement together. The question says this is a statement question. Both CONH3 whole 6 plus 3 and COF6 3 minus complexes are octahedral but differ in their magnetic behavior. So this is a question from coordination compounds, a straightforward question. So if I just look at the statement, let's start with it. Both are octahedral but differ in their magnetic behavior. Can you see, cobalt with ammonia is a special case, plus 3 oxidation state. So NH3 will act like a strong field ligand, whereas in COF6, fluorine will act like a weak field ligand, right? Okay. When it is a strong field ligand, it prefers, what? Pairing of electrons. And that's why they'll have different magnetic behavior. Whereas fluorine on the other side with a weak field ligand, it won't prefer pairing and the electrons will remain as it is. So cobalt is like 27. So cobalt 27 is what? It's going to be 3d7 4s2. So if I talk about cobalt plus 3, so that will be 3d6. And when it is strong field ligand, the pairing of electron will happen 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. This is how cobalt 3 plus looks like. When it is ammonia, the strong field ligand, obviously, obviously, the pairing will happen and will apply the crystal field splitting energy T2G and EG. The electronic configuration will be in a way that all the electrons will be paired. So the first statement seems to be true. Look at the second statement. Is diamagnetic. The complex with ammonia as the ligand is diamagnetic. So that means, yes, this is also true. Whereas the complex with the fluorine is paramagnetic. That means, all right, so this is paramagnetic. Both the statements are true. That means option 1 and 2 is correct. Let's check the answer. Yes, that's the right answer. I hope you were able to solve this question in the exam. Let's move on to the next question. All right, this question, is a mix of, I would say, organic and inorganic. The something from the organic hydrocarbons part and some part from the chemical bonding, the number of sigma and pi bonds, and C part is a special case that we teach you in the molecular orbital theory, right? C2 is a molecule which have two bonds and both the bonds are pi bonds. That's the special thing about C2, and that you can derive from the molecular orbital theory. The electronic configuration when you write both the bonds are the pi bonds. All right, let's talk about the options one by one. This is match the following. So ethane, on one side you have the molecules, on the other side you have the number and types of bond between two carbon atoms. That is the special thing. You have to look at the carbon atoms. So ethane, it's a saturated hydrocarbon, carbon single bond. So one sigma bond. A will go with 3. All right, neither option 1 nor option 2. Ethene, we know ethene, ethene is something like this. So it has 1 pi and 1 sigma bond. 1 pi, 1 sigma. So B will go with 4. B will go with 4. B will go with 4. No, we can't find the right answer because both the B's have 4 here. Ethene, next the C2 molecule, carbon molecule. It has both the pi bonds, right? So 2 pi bonds. I can see this in 2. C will go with 2, and that is the deciding factor. So the right answer is option number 3. You do not have to check for ethine, although we know ethine is like CH triple bond CH. and that'll have 1 sigma and 2 pi bonds. So what is left? 1 sigma 2 pi is 1. So D is with 1. That's where option number 3 is the right answer. All right. Cool. Moving on to the next question. The question from solution chapter, Henry's law constant KH value of three gases ABC in water are this kilobar respectively. The solubility of these gases in water follow the order. Solubility of these gases in water. If you remember, the KH value that used to tell that higher the value of KH, lower will be the solubility or the mole fraction of the gas in the solution. Let me write the formula for you. Pressure of gas is equal to KH into mole fraction of gas. That's the formula. Now, if you observe properly, KH is inversely proportional to solubility. How is that? KH will be pressure of gas upon solubility of gas. So I can say that, yes. So if the value of KH is high, the solubility will be low. So you need to arrange that in the, descending order. So the highest value, 145. Yeah, that's the highest value for A. So A should be minimum. I can see only option number 2 as that option. So if I just observe, yes, that's the correct answer. See, NEET is not about, solving the question correctly. It's about solving it in minimum amount of time, right? So that's what the key is. How you can, minimize your efforts and find the right answer. I just calculated for A and I am at the right option. And that, that comes with practice. And I hope you're able to do that in the exam as well. Moving on to next question, 79. The question is from, the atomic structure. So the energy of the electron in different shells. The energy of an electron in the ground state environment for helium plus ion is minus x joule. All right. Then that for an electron in N is equal to 2 state for beryllium 3 plus ion in joule is, okay. So you have helium plus and you have beryllium 3 plus. These are the two ions, right? So if I talk about energy of electron, if I talk about the energy of electron, it is proportional to minus z square by n square. Energy of electron, according to the Bohr, energy of electron in nth shell is proportional to minus z square by n square. Now, for helium, the z is like what? 2, and they are saying n1. So I will say the ratio will be 2 by 1 whole square. For beryllium, if you check, the Z value is hydrogen, helium, lithium, beryllium, 4. In the end, they are saying 2 whole square. If you'll observe, the ratios are same for both of them. That means if for helium plus ion, the energy of electron is minus x joule, for beryllium 3 plus ion also, it is going to be nothing but minus x joule only. So that's the option number 1 is going to be the correct answer. Let's check it once, and that's correct, right? Moving on to the next question. The question is from E naught value. The E naught value for Mn3 plus and Mn2 plus couple, 3 plus to 2 plus, that's reduction, is more positive than that of chromium 3 plus to 2 plus or Fe3 plus to 2 plus due to the change of. All right. So a nice question, a tricky one, So you need to be aware that manganese 3 plus, the electronic configuration is D4. And for Mn2 plus, it is D5. So D4 to D5, you are moving, right? So D5, D can have maximum 10 electrons. So 5 is half and fully filled orbitals are extra stable. And that is the reason D4 to D5 configuration. That is the reason why the E naught values of Mn3 plus to Mn2 plus is more than the other two values, right? Okay. That means option number 3 seems to be the right answer to this question. You can calculate the electronic configurations for chromium and ferrous and ferric also for the different oxidation states, and you'll see that Only for Mn it is coming out to be, the half-filled orbital, d orbital. That's why it is extra stable and the value is more positive. The reaction Mn3 plus to Mn2 plus is going to be more spontaneous in this case. I hope that makes sense. Cool. That's the right answer. Moving on to the next one. Still, we are in that section where each and every question is compulsory, right? So you have to attempt all these questions. The question says the reagent which gives glucose does not react to give the corresponding test products are. I would rate this, question a difficult one because you need to know all the reactions that glucose shows, with all these reagents, right? So you need to know all the reagents. You need to know what reactions they show. A lengthy one and a difficult one question, right? But all these reactions are there in NCRT, and we do teach them. So it's not a difficult question, at least for you guys. All right. So tolerance reagent, the glucose has the aldehyde group. The cyclic, when it converts into the linear molecule, the aldehyde group will get oxidized. So yes, this will react with glucose. But the question says does not react, right? So this is not the right option. Schiff's base, it's a weak reagent. It is not able to break the chain, break the ring of the glucose, and that's why the aldehyde group is not free, and that's why Schiff's reagent does not react with the glucose, right? This reaction is not shown. HCN, the cyanohydrin, that reaction, aldehyde, it shows with HCN, COHCN, right? That will be formed, and that's why this is also not the right option. NH2OH, oxylamine. This reaction is shown by the aldehyde group of the glucose, and that's why. This has to be correct, right? Because Schiff's is not showing the reaction. That's why it's correct. So NH2OH, it also shows the reaction. So this is also not the right option. Sodium bisulfite, again, this is a weak reagent, won't be able to react with the aldehyde group because it's in the ring form, and that's why this is also the right option. It does not show reaction with glucose. So that means B and E should be the right option. That's option number 3. Let's give it a check. That's correct. Great. Great going. Keep learning, keep moving. And the next question is from, again, coordination compounds, the isomerism part, right? So this time the questions have been asked from those areas from where generally, the question doesn't come up, right? So that's something good. And if I look at the question, so look at the molecule. I see in option A, in the molecule A, NO2. So NO2 is capable of showing, it's a ambidentate ligand. It can show linkage isomerism. At one time, nitrogen can be the donor atom. At the other time, oxygen can be the donor atom. And that's how the linkage isomerism can be shown by this compound. So I'll say A will go with 2. A lot of match the following questions this time, right? Yeah, that's one way the examiner makes the exam lengthy. One match the following question is equivalent to 4 questions, right? So that's what the key is. So if you are, if you're running short of time, you should avoid doing lengthy questions, and match the following sometimes can be a little lengthy. Moving on to the option B, I can see that the ions can interchange. So obviously, the bromide sulfide. So this time it is going to show what ionization isomerism, right? So this goes with this. B will be 3. All right. Next, what do we have? We have 2 coordination entities in one single compound, right? So obviously it is going to show the coordination isomerism. The ligands will interchange their place, and that's how it will show coordination isomerism. I can say C will go with 4. D, COH2O whole 6 Cl3. Obviously, the water molecules will move inside and out of the coordination entity, and that's why the solvate isomerism will come into the picture, right? So I'll say D will go with 4. Oh no, one solvent isomerism, right? So 2341, 2341. I can see that in the option number A. Option number 1 is the right answer. Cool. All right. Moving ahead. Next question. A question directly from NCRT. That's what the beauty of NCRT is. You see a lot of questions directly coming from the lines of NCRT, and that's why we keep on telling our students you should read NCRT line by line at least in your whole preparation once, at least once, And the ideal scenario is you should revise your NCRT 5 to 6 times in your whole preparation. Cool. So arrange the following elements in the increasing order of the first ionization enthalpy. So lithium, beryllium, boron, carbon, nitrogen, all are in the order, and we know beryllium because of the fully filled. I just told you, we are using the same concept again. Half filled and fully filled orbitals are extra stable, right? So beryllium, it has S2 configuration, and that's why the order that we generally teach is beryllium here, boron, and then it is carbon, and then it is nitrogen. So what do you see here? It's a reverse of order. So if I look at the option 2 seems to be the right answer. All right. So yes, that's the correct option. I hope you are able to solve this. Let's move on to the next question. All right. So look at this question. A question from basic concepts. So the neutralization reaction, 1 gram of sodium hydroxide was treated with 25 ml of 0.75 molar HCl solution. Okay. The mass of the sodium hydroxide left unreacted is equal to. And after reading this statement, some of the people might say that sodium hydroxide is going to be the limiting reagent, but that's not true. If you look at option number 3, it says 0 milligrams. So it might be possible that sodium hydroxide might have finished. So that we'll be able to know only when we calculate the values, right? So the reaction will look like NaOH plus HCl giving us NaCl plus water, right? So you have been given 1 gram. I'll convert that into the moles, 1 by 40. HCl is 25 ml into 0.75 mole, right? So molarity is moles by volume. So moles will be molarity into volume. So volume has to be taken in liter into 0.75, keeping it as it is. So these are the moles of NaOH and HCl. So if I just calculate these moles, 0.025 into 0.75. So this value will be, let me just calculate this, 75 into 25, 525, 75, 35, 37, 5 to 15, 7 to 14, 15, 5, 7, 5, 2, yes, 5 to 5 to 10. Yes, this will be 0, 7 to 14, 15, 5, 7, 8, 1, 1875. All right. So with 5 decimal, it will be 0.01875. So that's 0.01875. All right. What is 1 by 40? 1 by 4 is 0.25. So this will be 0.025. All right. I need to subtract this. Yes, I could have avoided the calculation part. I can take 0.025 NaOH minus 0.025 into 0.75. So this will be 0.025. 1 minus 0.75, 0.025 into 0.25. The square of 25 is 625. So it'll be like what? 0.00625. This is the moles of NaOH. Multiplying it with 40.0625 into 4. That will be nothing but 0.025, 250. And I have to answer this in milligrams. So the final answer is coming out to be 250 milligrams. So option number 2 seems to be the correct answer. Let's see. Oh, yes, that's true. That's true. The calculation was a little tricky, so you have to bear with it. You have to take a calculated call whether you're doing when you're doing the exam. You need to have your eye on the time, and if you feel like the time is running fast, you have little less time. Keep these questions for the end, right? All right. For the reaction 2A plus giving B plus C, Kc is this. At a given time, the composition of reaction mixture is this. All right. So the statement says then which of the following is correct? Reaction is at equilibrium. Reaction has a tendency to go in forward, backward, and forward direction. Completion. Okay. So basically, this is a question from equilibrium about what? Uh, yes, you need to calculate the QC value. All right. So QC will be what? Concentration of B into C by A square. Right. Okay. So I can see all the values are same. That means they'll cancel out, and the value of QC will come out to be 1. And I can see Kc is a little smaller. So QC is greater than Kc. That's what I can derive from it. If QC is greater than Kc, then what can I say? That means the reaction has to move in the backward direction, right? That's how we used to do it. This is the value of Kc. If QC is here, assume it to be the number line. If QC is less than Kc, reaction will move forward. If QC is here higher than Kc, reaction will move in backward direction. So that means option 3 seems to be the right answer. Let's check it out. And yes, that's true. All right. So till here it was till 85 question. And these were the all questions that you need to attempt, compulsory question. And now it's a choice. Although we're going to do all the 15 questions from 86 to 100, but let's see. In the exam, you have to choose 10 out of these 15 questions. So I'll try to tell you which 5 questions I would have avoided if I would have been giving the question live, right? I'll be telling you that as well. And let's see if it is matches for you and me both, right? So the question says given below are certain cations using inorganic qualitative analysis, arrange them in increasing group number from 0 to 6. All right. So, the people who have done the experiments properly, taken care, you gave, enough importance to the experiments in your school. So this question was a cakewalk for you. Aluminium belonging to the third group, copper belongs to the second group, barium belongs to the fifth group, cobalt belongs to the fourth group, if I'm not wrong, and magnesium is from the sixth group, right? So that's how the order is. Yes. Now you cannot guess, you cannot use your brain in the exam. Either you know it or you do not know it. So because I know it, so I've done it. If you do not know how the ions are arranged in the qualitative analysis in different groups 0 to 6, no need to attempt, you can skip the question. So according to this, B, then A, then D. B, A, D is there only in the first option. That means this is the correct answer to this question. All right, let's check it out. And yes, that's true. Next question, the product A and B obtained in the following reactions respectively are. This is a famous reaction to convert alcohols into alkyl halides. We studied this reaction twice, one in the preparation of alkyl halides and one in the reactions of alcohols, right? So I hope you remember this. The reaction used to take something like this. This is Cl, PCl2. So R would go with Cl, and the OH group was supposed to go with phosphorus, and then this reaction will repeat 3 times, and RCl 3 moles will be formed, and your A will be nothing but POH whole thrice. Another way to write POH whole thrice is H3PO3, phosphorus acid. Next is ROHPCl5, RClHClB. You have to figure out what B is. And if you remember, we used to do it like this. ROH, and you have phosphorus, chlorine, PCl3 here, chlorine here, and chlorine here, right? So that's how we used to teach it. You know, that's how the rearrangement of the atoms takes place. And this is one way to learn how this reaction happens. And what you get as the product is RCl plus HCl plus POCl3. So B is nothing but POCl3. So if I just look at A and B, you have to be careful. First one says B and A. So you have to choose A and B, H3PO3 and POCl3. That's an important point, guys. Even after finding the right answer, people tick on the wrong option and lose marks. You should not do that. You should be very, very careful while marking the right answer. Next question, mass and grams of copper deposited by passing this much amount of current through a voltmeter containing copper sulfate solution for 100 seconds is. All right, all right. The question from first law of Faraday, right? So what was the formula? W, the most, I'm writing the most simplified formula, MIT by Fx. All right. So molar mass is given as 63. Current, they are saying 9.6487. 9.6487. It was 63 molar mass. And then the time is 100 seconds. All right. Simple calculation. Then you have F. F, the value of X, F is given 96487. This is the more accurate value. Otherwise, we use 96500. That is the approximate value, right? If they would have not given, we might have used it. Okay. And the value for X, this is copper sulfate, right? So copper sulfate will have copper 2 plus charge to deposit copper. 2 moles of electron will be required. So this value will be 2. So if I just solve this value, if I just solve this, I'll say this is 10 to the power minus 4. So this is 31.5 and 2. This will be minus 2. So this will be 0.315 grams. Look at the options. The option number 2 says 0.315 grams. So that's the right answer. And yes, that's true as well. Moving on to the next question. The plot of osmotic pressure versus concentration for a solution gives a straight line with slope this liter bar per mole, the temperature at which the osmotic pressure measurement is done at. So the question from solutions, so pi is equal to CRT, the colligative properties, right? So if I talk about the value of pi, okay, it says it's a straight line graph, right? So if I compare it with y mx plus c, so I'll say my slope m will be nothing but RT. Take it A as A, okay, because C is the concentration here. So M is equal to RT. All right. So this value of slope given is 25.73 liter bar per mole, right? So if I just put the value 25.73, R I have to put in liter bar, so that will be 0.083, and temperature is what I'm trying to calculate, right? Here the temperature comes out to be, the temperature value will be in Kelvin, right? So if I just calculate, temperature comes out to be, oh, just a second. So the temperature comes out to be in Kelvin, and that is 310 Kelvin, right? But if you look at the options, all the options are in degrees Celsius. So you need to convert that into degrees Celsius. Minus 273, that'll be 23 plus 10. 27 plus 10, 37 degrees Celsius. All right. So that means option number 1 is the correct answer. Let's check it out. All right. All right. All right. So next question. The question from organic, it's chain of reactions, right? So a number of conversions. You need to find the major product C formed in the following reaction sequence. So you have an alkyl halide, the propyl iodide, you are adding NaCN. So Na plus Cn minus, this will be like what? Cn minus will attack on this carbon, I minus will be removed. you'll have AsCH3, CH2, CH2, Cn. All right. Then it is the partial hydrolysis. Partial hydrolysis of cyanide will give you amide. The complete hydrolysis of cyanide will give you carboxylic. So this is partial hydrolysis. Partial. So you'll have C double bond O, NH2. Okay. Then NaOH, Br2, Hoffman bromamide degradation, right? Hoffman bromamide degradation. So this will remove the carbonyl group from the compound, and you'll have 3 carbons with NH2. Propylamine. Look at the option. Option number 1 is the right answer here. So if you look at this, yes, that's the correct option. To be honest, till now, if I would have been doing the questions, I have the possibility of skipping only question number 86, right? The chances are high because I might not know what is the correct order. I might get confused. So I could have only left question number 86 till now. I have to leave 5 questions, right? Don't forget that. So identify the correct answer. 3 resonance structures can be drawn for ozone. 3? Is it 3? It's there in the NCERT. It is not 3. It is basically 2 resonating structures, right? That's how we draw it. So incorrect. We have to find the correct one. BF3 has non-zero dipole moment. BF3 has non-zero dipole moment. BF3, trigonal, planar, symmetric molecule. All the vectors will cancel out. It is 0. It is also incorrect. Dipole moment of NF3 is greater than that of NH3. All right. Again, a statement from NCERT. NF3. If I just draw NF3, the dipole moment for NF bond will be towards fluorine because it is more electronegative, whereas we assume the dipole moment of the lone pair is always upwards. So they are in opposite direction, they'll cancel out. Whereas for NH3, if I draw NH3, the dipole moment is towards nitrogen, upward direction, and for the lone pair also it is upward. So there, the addition sum of the vector is going to take place. The dipole moment, it just adds up in this case, and that's why NH3 has a higher dipole moment, whereas in case of NF3, the dipole moments will get cancelled. So NH3 will be greater than that of NF3 in terms of dipole moment, but the statement says reverse. That's why it is incorrect. So the only correct statement is 4. Let's read it. 3 canonical forms can be drawn for carbonate ion. We know, yes, we have done it multiple times. Carbonate is one of the favorite examples that we teach. So that's how carbonate looks like. And now this double bond will be repeated in 3 different structures. And these are the 3 canonical forms or the resonance structures for carbonate ion. So yes, option number 4 is the only correct answer. Option number 4 is the right option. All right. So again, a statement question. CONH3 whole 6 is a homoleptic complex, whereas CONH3 whole 4 Cl2 is a heteroleptic complex. We can tell that even with the closed eyes. Yes, that's true. Homoleptic, something where same ligands are present. Heteroleptic, where more than one type of ligands are present. So complex has only one kind of ligand, but this complex has more than one kind of ligand. So the statement 2 is the reason. So only option 1 is correct. That means, yes, that's true, right? The simpler question, a simpler one. 93, moving on to this question. So I can see a double bond over here, KMNO4 in the acidic media. That's, the cleavage, oxidative cleavage will take place. And what will happen? So if I just tell you, this pi bond will break from here, right? So the one pi bond will break, it will be OH here. Another pi bond will break, it will be another OH here. And there will be one more OH. removing the hydrogen. So what will happen? There, when multiple hydroxy group are there on the carbon, there is a loss of water molecule. And finally, what you get is C double bond OH. Carboxylic group will be attached. Both the molecules are similar. So the only major product that will be formed will look something like this, C double bond OH. Right? So if you look at the option, 1 not correct, 2 is the only correct option. Right? So 3 and 4 are also found. They are intermediates. They are found in between because KMnO4 is a very strong oxidizing agent. It will not stop the reaction in the middle. The oxidize cleave, the bond cleavage of all the bonds will take place, and the carbon will be oxidized to carboxylate finally. All right. That is also fine. Let's check out our answer. And option number 2 is correct. Great. Moving on to the next one, the pair of lanthanoid ions which are diamagnetic is. I would recommend leaving this question if you do not know, the oxidation states and the electronic configurations of the lanthanoid. But just to solve this, Ce4 plus, it is F0, ytterbium 2 plus, it is F14. Both of them are diamagnetic in nature, and that's why this is going to be the right answer. This is also a question, either you know it or you do not know it. No chance of flukes in it or calculating or any calculation. So that's what the correct answer is. So this is the second question that I'm going to leave. 5 questions and 3 are there, and I have to leave, out of 5, 3 I have to leave, right? So look at this question. Again, a question from equilibrium. Yes. Consider the following reaction in a sealed vessel at equilibrium with concentration. These are the concentration of N2, O2, and NO. The reaction is given NO dissociating into N2 and O2. If 0.1 mole per liter of NO is taken in a closed vessel, that will be what will be the degree of dissociation alpha of NO at equilibrium? To be honest, this is the also question that I'm going to leave. Not because it is tough or difficult, it's because it'll include calculation. It is going to be a lengthy question, right? So let's see what is the approach for this question. 0.1 mole per liter of NO. All right. We have to calculate the degree of dissociation alpha, right? Okay. So if I just write this reaction, 2NO converting into N2 plus O2, right? So I have taken C1 minus alpha. So that will be C alpha by 2, C alpha by 2. Tell me in the comment section why I am dividing this by 2. Right? Just let me know this. So if I write the Kc value, that will be concentration of N2 into concentration of O2 upon concentration of NO whole square. Right? That's how it is. Okay. The concentration that are given to me are at equilibrium. So I'll use this and I'll use these concentrations and I'll equate this into the Kc value. So let's see. So N2. This is 3 into 10 to the power. Oh, let me change the color of my pen. 3 into 10 to the power minus 3 into 4.2 into 10 to the power minus 3 upon NO whole square. 2.8 whole square into 10 to the power minus 6. All right. Is equal to C alpha by 2 into C alpha by 2 upon C1 minus alpha whole square. So C will get cancelled with C square. So what you have here is alpha square upon 4 1 minus alpha whole square. Okay. So this is like what? 3 into 4.2 minus 6 minus 6 minus 6 upon 2.8 whole square into 4 is equal to alpha upon 1 minus alpha. This will be under root. So if you'll solve this, the value of alpha that you get here is nothing but 0.717. I'm just avoiding the calculations. So if I just look at the options, yes, option number 4 is the correct answer to this question. I hope you understood the approach that we have used to solve this. I've just equated, the different values, and that's how the equation have been solved finally for alpha. All right. So again, I told you I'm going to leave this question in the exam, right? It's a lengthy one, includes more calculation. A compound X contains, next question from empirical formula, a simpler question, 32% of A, 20% of B, and remaining percentage of C. Empirical formula for X has to be calculated. Atomic masses of A, B, and C are given. So that's very simple. So if I do it for A, B, C, the ratio will be what? For A, 32 by, I'll read 32% as 32 gram of A in the total mass of the compound, right? So given mass of A will be 32 and the molar mass is 64. The ratio comes out to be 1/2. For B, it is 20%. So 20 by 40. All right. Again, it is 1/2. And for C, it is like what? 32 plus 20. How will I calculate C? 100 minus 52. That means C will be 48%. So I'll write 48 by the molar mass of C, that is 32. So this is like 16 into 3, 16 into 2, 3/2. All right, the simplest ratio for A is to B is to C is nothing but 1:1:3. All right. So if I just look at the option A, B, C, 3, option number 2 seems to be the right answer. To this question, I would say that, if I find more difficult question than this in the upcoming questions, I might do it. Otherwise, I might leave it. Sometimes the calculation becomes tricky in the exam. That's how I'm keeping it in a zone where I might leave or might not leave. Okay. So moving on to question number 97, the work done during reversible isothermal expansion. Finally, a question from thermodynamics of 1 mole of hydrogen gas at 25 degrees Celsius from pressure of 20 atmosphere to 10 atmosphere is. All right. So work done formula for reversible isothermal expansion. If you do not remember the formula, the only option is to leave the question. Otherwise, the formula is minus 2.303 nRT log, because it is pressure, so it will be P1 by P2. If it would have been the volume, it would have been V2 minus V1, final minus initial. Final by initial. Here it is initial by final. So if I just put the values, minus 2.303, moles is 1, R is 8.314, temperature is 25, that means 25 degrees Celsius. So it is nothing but 298 Kelvin into log P1 by P2, 20 by 10. So that means log 2. So if you will solve this, there is one error that I have made. Can you just figure it out? Yes, that's a common error that we make. The value of R I have put in joule per Kelvin per mole. Whereas if you look at the options, calorie, 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 calorie. So the value of R has to be put in calorie. So let me just remove it from here. This value has to be 2. Now if you solve this, the answer will for sure will come out in negative. So minus 2.3 into 2 into, I'm taking a little approximation, 300 into 0.3, right? This 2.3, 326. So this will be what? 23. This will be like what? 23 into 2. This will be 46. Let me write directly 46 into 9. So with a negative sign, I can clearly tell you the answer is going to be option number 2 without even solving it. I know 46 into 10 is going to be 460. So the answer has to be less than 460, somewhere close to 420. And because the negative sign is there, so the only option correct is option number 2. That's why I keep on telling, look at the options before you jump onto the final answer. Keep on looking at the options. Your eagle's eye should be there on the options. The moment you think that you're able to eliminate other options and you have the right answer, just leave the calculation there itself, tick on the right answer and move on to the next question. That's what we are going to do here, right? The next question: during the preparation of more salt solution, ferrous ammonium sulfate, which of the following acid is added to prevent hydrolysis of Fe2 plus ions? Again, a question from the practical chemistry. So Moho salt, it is used in the titration. We add for the lightest pink, the battle of the lightest pink. We fight that battle in the chemistry lab. I hope you have done that experiment. So it is a very common question that the Viva teachers, our respected teachers, they ask us in Viva that why do we add only dilute sulfuric acid? Why not other acids? So dilute hydrochloric acid, it interacts with the KMnO4, so this acid, again the same problem. So none of them will be used. It is only the dilute sulfuric acid that is used to provide the acidic media, and that's how. Yes, that's the right answer. So this is what is used to prevent the hydrolysis of Fe2 plus ion. So all right, all right. So if you do not know, if you have not done the experiments, so this might be a question that you would love to, you would not love to do in the exam, right? So next is the rate of the reaction quadruples when temperature changes from 27 to 57 degrees Celsius. So we are standing at 99 now. The heartbeat is high. We are about to come to the century, the 100th question. So quadruples. So I'll say the rate of the reaction quadruples. That means the rate constant will also quadruples with the change of temperature. So what is the formula? K2 by K1. 2.3 EA. Sorry, I'm sorry. So this is EA by 2.303 R 1 by T1 minus 1 by T2. That's the formula that you derive by taking two equations, right? So it says 4 times we have to calculate the activation energy by 2.303 R 1 by T1. What is the temperature? T1. We need to convert that into degrees Celsius, right? And you have to write the value of R also, 8.314. All right. Temperature 300 and 330. So 330, 300 minus 1 by 330. If you'll solve this, just to avoid the calculations, the correct answer is option number 1, 38 kilojoule, right? The EA will come out in joule, then you have to convert that into kilojoule, and that's how the option number 1 is the right answer to this question. Moving on to the last, but not the least, I might leave this question also because of the calculation part, right? Moving on to the last question of the day, and with that, we will end the session. So the question says major product A and B formed in the following reaction sequence are. Okay. All right. So if I look at the question, PBr3 is added to alcohol. So that's one reaction to convert alcohols into alkyl halides. We again study this reaction twice, one in the reactions of alcohol, one in the preparations of alkyl halide. So what is A here? So if I just try to draw CH3. Apologies for the disturbance. Will be Br here, right? You are adding alcoholic KOH, dehydrohalogenation, right? So the Seitzef rule has to be applied. The most stable, you are going to form the major product. The most stable alkene has to be formed, and that's how it looks like CH3, right? So if I look at the option, Again, in the last question, option number one seems to be the correct answer, right? This is the right answer. So yes, whenever the option number one comes, it is a little, uncomfortable situation. We think that, we are correct or not, because that's how the students, that's how the students are being tricked in the exam. The most probable incorrect answer is also kept one. But in this exam, we have seen that majority of the answers in chemistry, at least, were option number one. But you have to, trust your instinct. You have to trust your knowledge. You had to need to have that belief that whatever you have calculated in the exam, that's the right answer, right? So with that, uh, I'll wish you good luck for your upcoming result for the NEET. Don't be disheartened, if the score is not well. This is not end of life. Life is very big. You'll have more chances to come. So with that, I'll say goodbye to you, and keep following us, keep asking, ask ideas. Bye bye.